Hello, everybody, and welcome to the second session of this year's 16 4J. My name is Ivan Yonkov, and I'm the CEO of the consultancy Codexio. I will not talk about myself. The only thing that I will tell you is that they call me the Java archaeologist. Probably you can understand why in the next slides or not. Depends. Well, as I said, no more for myself. Let's go on. And the only thing I can start is that reflection is already dead and one-click annotation processing. The agenda is very simple. You already guessed it. We'll talk about reflection and we'll talk about annotation processing. What do I mean by all these two things? Is that we will solely try to find some solutions with metaprogramming to some things that probably will not gonna work well if they don't have any meta in it. And I will not use any frameworks, no libraries, so we can try to understand the things, how do they work under the hood. I understand the fact that there are a lot of frameworks and libraries that leverage reflection, annotation, processing, make it easier for you, or even hidden for you that it happens behind the scenes. But this is not the idea of the today's session. Today's session is mainly focused on what reflection solves, maybe why it's not insufficient, and how to use annotation processing for the very same task with better results. So let's start with something that we call it abstraction. You already know from the object-oriented principle that we call what we call abstraction. The only thing that I want to show you here is one counter example where abstraction is not used, then how to use it and how to glue it to your application and using some meta for that. So let's imagine we have certain ways to log in into our applications with credentials, with tokens, with certificates, and so on and so forth. Sometimes you may see the code written this way, sometimes not, but let's imagine it is written this way. Well, then we go to a rabbit hole where you can have nested conditionals, like if it's a credential login, we need to have to check whether it's password login or social login, depending on what request is given to it, and then take certain actions about it. The same can happen for token exchange login because maybe you can have some steps inside it, like should we verify the issuer, should we not? For the certificate login, it can be the same. We may have some steps after we know that it's certificate login, whether we need to allow self-signed certificates or whether we need to allow certificates that are expiring in the next 1 month. And things can get even worse when we have these different configurations depending on different clients. For instance, we can have some clients X and Z that have verification for the issuer, but Y, for instance, doesn't need any verification. The same can happen for the other types of logins. The self-signed certificate might be disallowed only for two of your customers, and the other customers might still want to use self-signed certificates. So if our code base grows into this, probably our colleagues and ourselves will get very grumpy. And yeah, of course, here the solution is the abstraction. The abstraction here is one interface authenticator, which abstracts in a function called authentication, authenticate, the job for all of these authentications, accepting the request. Of course, different implementations, credentials, certificate token, and even subclasses of them. Password credentials is one subclass of the credentials authenticator. There is one nested thing here, as you've seen in the example, we had some steps that need to be performed. So we need one more abstract thing that's called step, which can execute itself and probably execute the next steps because we may have a chain of steps configured for our customers. For instance, a step for verification of the issuer of the certificate, a step that allows or disallows the self-signed certificates, or a step that probably disallows the expiration of the certificate in the next 1 month. That's fine. If we have this code base, it's pretty good. But this code base is not gonna work magically for the things that we had in the previous slide. How we can configure these things in our code base to be there? Who will instantiate all the authenticators? Who will instantiate all the authentication steps? And who will map them to certain channels, for instance, X, Y, and Z? Well, probably we need to specify it somewhere, either in the code or in external configuration. And if we have some environment that differs from another, probably it shouldn't be in the code and certainly in a configuration. Where we have for channel X that the allowed authentication types are token and certificate. For channel Y, it's only certificate. And for channel X, it's not only token and certificate, but then we have steps that are verifying the issuer and allowing self-signed. But for Z, it's not only verifying the issuer and self-signed, but we also have should not expire on the next month. Still, very good, correct? But who will take this configuration and map it to our code base? Well, then obviously we need some metaprogramming to see it from the above, take all the strings here, match them to class names from our code base, probably instantiate these class names, and probably map them to some mappings like hash map or something that it's tied to a certain channel. So it's not going to happen by itself. We need to use some technology that allows such inspection of classes. And one very popular technology is called reflection. It's in the Java API, where in the runtime, you can inspect classes, check methods, instantiate them on the fly, and do a lot of other things with the meta information present for the class. So for this example, let's say we need to get the steps and add them in one hash map. Only for this, we need to have such code base. We compile all our classes, then go to the output directory, in this case bin. Then we find any file there. We check if it ends with .class, and then we start the job. Take the full qualified name of this class, then check if it has some annotation. Is annotation present? Is actually a method from reflection. Then get annotation is reflection, and get constructors is reflection. So everything here uses the reflection API to create one hash map called registry that has as a key the name of the step, for instance, the allow dash self dash signed, and on the right side, the actual object of this step. So we can use it later in our code base. And this example is very oversimplified. It works the exception handling, it works any full qualified class normalization, the recursive parsing, and the constructor instantiation is also something that is not addressed very well because maybe we can have constructors with different arguments, and it's also not covered here. So if we need to cover this, the code base will grow enormously. And there is one more problem, is in reflection. Let's imagine we have this object here, this record user, and we want to create 10,000 instances of random names and ages. If we do this normally, we can do it this way. Iterate 10,000 times and then print some stopwatch to see what is the performance of this. But if you want to do it with reflection, we need to take the class name dynamically, let's say bg.codexio.something.user. Then we need to find the appropriate constructor by the arguments, the necessary string and integer. Then we need to call new instance, which as a code is not that much, but it has performance degradations that are very significant. And if you don't believe me, you see it now. You see the normal instantiation takes 3 milliseconds and the reflective instantiation takes 20 milliseconds. Now you can say, hey, Ivan, you ran it only once, maybe it's biased. Well, second time, it's even worse, and worse on the third time. You can say, oh, okay, but in some of the cases, we know that the user class is present. We can do it not with the magic string. Well, in most of the cases, you cannot. But even if you could, for instance, this way, user.class instead of class.foreign, it's still pretty bad. Now, what about frameworks that uses reflection like Spring? Well, Spring Boot application with only Spring Boot Starter Web, without any other classes in my machine starts for half a second. And it gets even worse when you have some repositories and some um, services because it goes up to 3.5 seconds to run every time when you run the application. And this can be a problem. Well, two reasons it can be a problem. If you do it in the runtime, for instance, on each user request, you may degrade the performance of each request, spend more time on a single request, then utilize your CPU for much longer time. And sometimes when you have more requests, then they will get slower and slower and slower. If you try to optimize like Spring are doing and do it only on the startup, it's better for each request, but still your application boots for 3 seconds and probably 20 seconds, which means that even if I have the same code base, the same jar, if I want to start it, it can take me 4, 5, 10 seconds to start it without any modifications. I don't compile it second time. I have it compiled. I need to double click the jar file and wait 10 seconds. For cloud environment deployments, it's bad. You need to restart your pods in Kubernetes, for instance, and then you wait for 20 seconds downtime. Well, it's not downtime in Kubernetes. Maybe you have previous pod there, but still, if you need to kill them all, you need to wait. That's something that you may want to avoid. How? Well, this is the annotation processing coming in place. What is annotation processing? Well, let's imagine we have three classes, one of them annotated with the annotation builder, and then we throw the JavaScript compiler. This is pretty standard procedure. We will just receive three classes in the output folder. But if we have an annotation processor, we can specify it as a flag proc. And then this processor will plug into the compilation phase and output a new class and even a new Java file. What does this mean? This means that all the reflective operations, we can make them compile to source code and then to bytecode, which means there will be no more things that will happen upon startup. It will happen only once during compilation. And when you have the same jar and run it over and over and over again, this will not happen anymore, like it's happening in Spring. So this is one of the things. The other thing that you have as a benefit here is you have the actual Java files and class files that you can decompile. So when you click somewhere, you can see the real Java code and not some gibberish like class.for name.new instance and so on and so forth. And this is very well written in a JSR 269, which proposes how the annotation processing should happen. It's there for 2 decades or even more. Hence, me, the Java archaeologist, making it pop above the ground so people can use it. And it leverages one main class that's called processor, which is implemented by an abstract class. There are two interesting things here, the processing environment and the rounding environment, both of them giving you essential things about the metadata. The processing environment is added to a field that you can use later because of this abstract processor, which says, okay, just say it one field and initialize the class. What you can find in the processing and rounding environment, there are some very good utility methods for elements and types, or for root elements and elements that are annotated with some annotation. For instance, typeutils can give information about primitive types, making comparison whether one class is a class of another one. And the element utils can give you some information about packages, members inside this class. So you can have pretty much almost everything that you have in the runtime reflection during the compilation phase. One very small example of annotation processor is this. You create a source file called example created file and put the Java code here. It will just get compiled once when you call the Java-C compiler on your whole project. Yes, creating Java from strings might be inconvenient. There are libraries that help you about it. For instance, Java Poet, you can use it, that you can programmatically create classes instead of writing magic strings or templates or something like that. But in this session, we're trying to be very low level so you can understand it under the hood. So let's imagine a situation where we have an interface course and two implementations, Java and Python course, and then we need to create a factory that creates them both. That's very standard scenario. The only problem having such scenario is that your code base violates the open close principle. If third course, C# course, or PHP course, or JavaScript course comes, you not only need to create new class, which is perfectly fine because you can create it in another jar or something like that, but you need to go back to the course factory and add new case. This is not only inconvenient, but even in some cases not possible because, as I said, these classes might be scanned from some jars and you may even not know about them. So what if we can make this course factory generated? We can. Let's start with one annotation called factorize that we will create. This is custom annotation, which have two things. What is the full qualified name of the factory that we need to add this class to, because we may have a lot of factories inside our code base. And what is the key that it will be used in the switch case, for instance, case Java. And put it above the Java course. The Java course says, okay, your factory will be course factory and your key will be Java. For the Python one, the situation is the same. The factory full qualified name is again the course factory. This time the key is Python. Then the hardest part, to create the factory processor that spits over this code base. Well, some things that we instruct our factory processor to look up only, to be invoked only for the factorized annotation, and it will support the latest Java version. Then we need to have the process method that will do the actual work, but we need some helper structures to do it. Because we may have a lot of factories, we need to have them in a hash map where the string is what is the factory, the key, and the factory method details hold what is the name, like create, it was in the Java course factory, what is going to return, for instance, course, and what are the cases inside the switch. So we can split all the factories at once. How to start? Well, we need to know whether the processing of the classes is finished. If it's not, we can do it. We can find all the elements that are annotated with the factorized annotation, then get the actual annotation, take information for it. What information do we need? Well, to construct the switch case, we need information. What is the key, like case Java? What is the second thing we need? Well, what to return? Return new something dot Java course. And we need to add this to the factory cases of the course factory and not for any other factory. With the method create, and the return type is the implemented interface, which is course. After we add all the switch cases to all the factories in the factory cases hash map, we need to write this as Java code. And how we can do it? Well, we need to have some string manipulation. I already told you we can use some library, but just to be on the same page, we don't do it. because we want to see what happens behind the scenes. And behind the scenes, there is not much at this case, of course, because we need to say what is our package. And the package should be probably the package name of the other courses. This is the full qualified name that's given inside the annotation, but only the package from it, like last index is taken, so on and so forth. Then we need to say what is the name of the class. Well, from the full qualified name, then we strip the package, leave only the right part, which is the course factory. Then we need to know what is the return type. We already did it by doing the new factory method details, adding the interface of the classes. So when we introspected Java course, we saw that it implemented course interface, and this course interface will be added here as a return type. So it will be public course, then blank space, then what will be the method name? We hard coded it before to be create, so it will be public course create, then string name, then new line, and switch against this name. And now all the things that we added in the cases can go here. The method details.cases will have all these keys and arrow the new Java course or new Python course. If we run our processor, we can see it, but to run it, we need first to have it in some other project. So, this is our project, factory processor, and it has one little thing to specify that we have a processor inside this application. In the metainf/services, we have processor file, which says here we have the factory processor. And since we don't use any other libraries, we also don't use Maven, Gradle, or something else, so we compile it by ourselves. What we do to compile it is just go to the source folder and compile all the Java files, nothing more than that. Then when we have all the files compiled, all the files compiled, then what we do is creating the jar. What we do here is all things are compiled inside the /bin directory, as you can see on the second variable, and this metainf services is already pre-created, so we need to add it in the jar as well. When we add this in the jar, we're ready. We have jar file successfully created. And if we now look in our bin folder, you can see the jar file there. So how do we use it? Well, again, in our main project, which is the one that contains the courses, we need to compile our files the same way we did with the annotation processor. Again, every file that is with .java, that ends with .java, should be compiled. So the Java C compiler is invoked to all of these files. That's fine, but we also say that the class path will not be only on our bin directory, but it will be the path where the annotation processor is. In this processor is added with the flag dash processor that says the factory processor needs to be run when we run the compilation here. And the Java compiler will invoke it. So we will receive the Java course.class and the Python course.class, but also the annotation processor will create the course factory, Java, and class file. If we look what happened, this is the generated course factory.class. And the generated course factory.class have everything necessary, correct? It has a constructor, so you can do it with new course factory. Then you can say, okay, course factory, please dot create Java, and you will receive the Java course. Course factory dot create Python, you will receive the Python course. Well, not exactly, because when you go to your main method, you will not still see it because it was in the bin folder, and probably your ID scans only the source folder. So you need to instruct somehow. For instance, you can go in IntelliJ and say that your dependencies will include the bin folder. It's kind of inconvenient. There are ways to overcome it more easier, but uh, not that many because this class was not present before you started developing. You need to compile one time to receive it. And there are a lot of other ways we can approach it. For instance, we can use bytecode manipulation to precompile the class, have nothing in it, and then with bytecode manipulation to put everything necessary, or even to rename one class to another. But this is things for another topic, and we cannot cover it today. But please do tell me if you want it on the next time, maybe. So, thank you, everyone. I hope you enjoyed the session, and I'm here for any questions if there are any. Otherwise, you can find me offline on LinkedIn with /in/Ivan Yonkov, or you can find our works in GitHub and probably help us with some of the open source to be greater than it is. Thank you again. I'm here for questions. Please tell me if there are any. Bye.